In this video, we will look at the code for issuing a book, and then the code for getting the transactions from the library system for a member on a certain date. Issuing books is a little easier than getting the transactions, so let's go over this first. When the member wants to issue a book, the actor will issue the appropriate command, and the method issue books in user interface will get called. You can take a look at the actual code, but here is the pseudocode. It gets the member ID and puts it into a request object and sends it to the library, which goes to the search membership method of the library. And then if it is successful, we loop here, getting a book ID, put it into a request object, and use the member ID, which has already been validated with this book ID, to the issue book of the library class. And here we loop while there is one more book to be issued. So it is not a very difficult method at all. And you look at the result object to see whether the book was issued and what its due date is, etc. So here is the code for getting the member ID and calling the search membership method, etc. And the remaining code, which is in a loop, while yes or no, I keep looping. Try to get the book issued, and if it is successful, print out the due date, etc. Okay. Now here is the issue books in library. Just like add member or add book, it creates a result object, then searches for the book. And if the book is null, then set an appropriate result code and then return that result. If the book is already issued out, then book.getBoreover will not be null. Set an error code and return the result object. Look for the member. If that member ID is bad, the library cannot take a risk here. So that is why it is checking this. It sets the result appropriately and returns that. Once you get to here, we actually issue the book. We issue the book to the member by calling book.issue and member.issue. So the book records the fact that this particular member has borrowed it and that the due date is such and such, and the call to member adds this book to the list of books that the member has borrowed. And we will see that the actual code, that result is set, the result code is set to operation completed. Now, the code in the book class for issuing is like this. It sets the borrowed by field as this member who is borrowing this book, and it creates a due date which is 1 month from now. So it adds 1 month, and you have to jump some hoops to get the whole thing record as 11:59 p.m. 1 month from now. So one had to try some, I had to try some method calls, and then some things didn't work out. So this sequence does work. And the member class has this list, books borrowed, which is a linked list. And when a book is issued, it is added to this list. And if that is successful, we add a new transaction. We create a transaction with the type of the transaction and the title of the book. Add it to this list of transactions. If you look at all the functionalities that are required for either the books borrowed for a member or for the transactions created for a member, you don't need anything more than what is provided by the list interface. So there is no need for any custom collection class. But that is not the case with hold. You can read the chapter that is on D2L to see why the hold list is required, why it is different from the operations that are carried out on the list of books or on the list of transactions. Basically, it is because when you are talking about transactions, all you want to do is keep adding and then get an iterator. That is always provided by the list. Similarly here, what you want is simply adding books to this list and then removing books or locating those books, which are quite easy using this list interface. But that is not the case with hold. We will see that again in a different video. Let's talk about transactions. The transaction has a type, a title, and the date on which the transaction occurred. And this method on date simply checks whether all the date fields match, like the year and the month and the day, which we had a glance in the first video. And it is again reproduced here. Now, let's see how we get all the transactions on a certain date. This is a little difficult, so let's spend some time on this, a little more than what we have spent on other operations. So here, if you want to get the list of all transactions for a certain member on a specific date, what we do is we ask for the member ID, set it to the member ID field of the request object, get the date, and set the date in here. So those things are done. And then we call the get transactions method of library with this request object as parameter. And the library will return an iterator to a transaction. And from the user interface's viewpoint, it is very simple. We get an iterator to a transaction, and when you iterate, all the things that you get here would be falling on this date. Whatever the date the user entered, suppose the user entered December 15, 2018, then all the transactions that are recovered here would be on that particular date. But it happens in an interesting way, so that we need to look at. So each transaction is pulled and the information is printed. If there was a mistake with the member ID or whatever, then the iterator would still be valid, and this result will not be null in any case. So there is no danger of a null pointer exception in this code. So what happens in the library class? This is also not all that hard, but it will get a little more messy in the member class and and another class that we will see in a minute. All right, this is what happens in the library. You want to get all the transactions. The member ID and date are here in the request object. So you search for the member in the collection class member list, pulling the member ID. And if you get a member, if this member ID is valid, you come to this line. Otherwise, if member is null, we create a linked list of transactions that is empty and create or get the iterator for that. So this is a dummy list which doesn't have any elements. We simply don't want to return null, which is generally considered problematic because you have to check for those, and if you don't, you get crashes, etc. All right. Member.get transactions on date. This is a method obviously in the member class, and we are passing the date for which we need the transactions. So this is a valid member, and we need the transactions of that member on this particular date. What happens? Now you will see some code that looks quite hard. We will see what happens here. Well, it returns an iterator to a transaction. Get transactions on date, and this is the calendar object in Java. What we do is create what is called a filtered iterator, which is an iterator of type transaction. And you need two things. One is this filtered iterator needs an iterator for all the transactions. So the first parameter supplies to the filtered iterator all the transactions, or at least an iterator to all the transactions. And the second parameter is the test. What is the test? Given a transaction, does the transaction fall on this date? So this date is here. You must recall that on date is a method in the transaction class which checks if the given date is equal to the date in that transaction. So given a transaction, check whether the transaction falls on that date. So this is the test to be applied for every transaction. Now let us see how this actually works, what these things mean, and how it works. Let's see how the iterator works in our case. Suppose we have an iterator to transaction objects, and let's say there are 6 transactions, T1, T2, T3, T4, T5, T6. So these are all for the same member. And let's assume that T1, T3, T4, T6 all fall on this day that the user is specifying. So these may be all falling on December 15th, 2018, and the user may be wanting on that particular day. Then normally, how does the iterator work? The iterator will first fetch you T1, then it will fetch you T2, then T3, T4, T5, and finally T6. So that is what an iterator normally does. It gets things one by one. But the iterator that we are getting is now going to skip T2 and T5. It will first get you T1, and then if you say next, it is going to give you T3. And if you say next, it will give you T4. And then if you say next, it will give you T6. And at that point, if you check for has next, it will say, I don't have anything more for you. So you are not supposed to call next at that point. So we have an iterator that is filtering stuff. So we are calling this a filtered iterator. That is the name of the iterator. It's a pattern, a filtered iterator. That is the class name, filtered iterator. So how does that work? It needs the actual iterator to this list, which would give you T1, T2, T3, T4, T5, T6. And it needs that test. What test do you want to apply for filtering? So this fellow, this filtered iterator needs one, the iterator to transactions. The second thing is the criteria. What test should I apply to filter? Those two things must be specified for creating a filtered iterator. And the method get transactions on date in member, when given a date, would create the filtered iterator and supply the iterator to the transactions and the test. This is pretty easy to see. Transactions.iterator. We have transactions as a linked list and a declared type of list. So transactions.iterator would be the iterator to this linked list. But what does this mean? This is the test. Essentially, what you can view it is, given a transaction, does the transaction fall on this date? So it is calling the method on date on a transaction object. But how does it actually work? What does it really mean? For that, let's take a look at the filtered iterator class. Here is the filtered iterator class, and every filtered iterator object is also an iterator of transaction objects. So as you can see here, it requires an iterator to a transaction. And the second parameter is actually a predicate on a transaction. A predicate is a Java interface. It has just one method. As you can see here, predicate has a single method called test. So a predicate on a transaction is the second parameter. Those are the two parameters are stored here. And what does the test method do? It is supposed to return a Boolean. So it would be applied like this. So the predicate object, every predicate object should implement the test method. The interface requires that you implement the test method. It has exactly one method in that interface, that is the test method. Given an item, what is your test? So you have to specify how you are going to test it. Predicate.test. The predicate object is checking whether the item that you are supplying to it is satisfying the condition. So you need to implement the test. So what the filtered iterator is saying is, give me an object that will check whether the transaction is okay, is satisfying things. Now you recall that there is exactly one method in this interface predicate. This is called a functional interface. This is relatively new in Java. I mean, it didn't come out yesterday or day before, it came a few years ago, but it is still relatively new. It is called a functional interface. If you have a functional interface, you don't have to actually create a class explicitly to implement that interface. What we can do is do it like what we did in this member class. What did we do here? Well, we wrote essentially this transactions dot on date date. What this means is something to the following effect. We can write like this: public or private, doesn't matter actually, class, my predicate implements predicate transaction, and it is giving me an error because I haven't implemented the test. I need to import a predicate anyway, and also I need to implement all the functions in predicate. There is only one all the method in predicate. There is only one method. So given a transaction, what should I do with it? Should I say it satisfies the test or not satisfy the test? So I could write something like t dot on date, and I need to supply a date. So what date should I supply? Well, I need to have a date here. So I could, when I create my predicate, and I could supply a date. See, I'm implementing that interface, nothing more. So I will have a field which I haven't yet declared. So let me declare that field here, private calendar date. Oh, I need to, okay, got it imported. So given a date to the constructor simply stores that. And if you call the test method of this class, obviously you need to supply a transaction, and it will tell you whether the transaction falls on that date. So it will return whatever this on date method returns. So instead of this, we can simply create a new predicate and supply the date. Oh, new my predicate. Should be my predicate. This will do the job. But this is so much coding. And what it is doing ultimately is nothing but this. Given a transaction as a parameter, it will execute this piece of code. So for so little code, for so little actual execution, I had to write so many lines of code, 8-10 lines of code. Instead of that, I can simply say, given a transaction parameter, all I am doing is test whether it is falling on that date. This is the relevant code. Given the parameter t, I will be checking whether it falls on that date. So instead of all this long, relatively long sequence of lines, I can write T arrow T dot on date, which is the parameter which is known here. So this date is this one. These two are the same. And we are simply checking if T, given this parameter T, so that is this. I don't even have to specify what type it is. Java can infer it because it requires a predicate object here. So it knows that you are actually carrying out or executing this method test. So it knows that the parameter that you are passing is of type transaction. It can deduce all that. And you are using the same variable here, T dot on date. And since I don't like single letter variable identifiers, I'm going to call it transaction and change this to transaction. That is essentially what I had here, right? So that's it. This is called a lambda function. So I'm going to delete this. Okay. So this is the lambda function. So the function is being shipped. You're shipping a piece of code. Instead of creating an explicit implementation of an interface, the system is, from our standpoint at least, creating a class that implements that interface with this as the code for the test method, and this is returned. You don't have to say return, and this is the parameter. That's it.